Hi. In my last video, I asked AI tools to generate a humanoid robot design from my text prompt, and to convert it to a 3D model. Then from there, I manually added a kinematics model containing all of its moving joints. What I got in the end was a fully articulated custom humanoid robot. I decided to name it the Necklace Humanoid, because the 3D model was auto-generated from a front view image on which the neck was not visible. Finally, the Necklace Humanoid was put into its natural habitat, the physics simulation world, and it quickly fell on its face. Literally and figuratively. So, the goal of this video is to teach it not to fall, and maybe start walking. Controlling humanoid robots to walk has historically been a challenging problem due to the unstable nature of their dynamics, and uncertainties of the environment.
Yeah.
But the field has been making rapid progress lately. State-of-the-art humanoids from Boston Dynamics and Tesla have totally transformed from awkwardly mimicking human movement, to robustly performing tricky acts that most human couldn't do. But, as impressive as those demo videos are, it was very hard for a random person like myself to gain any detailed insight into their technology, or to apply their control approach to my custom necklace robot. However, there is always the open-source world to the rescue. OpenAI, yes, the ChatGPT company, released OpenAI Gym back in 2016. This Python library serves as a platform for developing and benchmarking reinforcement learning algorithm by providing a wide range of simulation environments all accessible through a standard interface. This humanoid example, in particular, looks very close to what I need. To make training magnitudes faster, from taking days to taking a couple hours, Nvidia has came up with Isaac Gym. By moving simulation and learning all to the GPU, people can training not one but thousands of copies at the same time, so Isaac Gym is what I am going to use. First I need to import my necklace humanoid. Luckily Nvidia provides a handy URDF importer making the process super easy. Before moving on, let's check our imported model. It falls down, again, as expected. But in a physics-obedient manner, and all joints are working, so everything is good. The next step is to define the reinforcement training task in Isaac Gym. Fortunately there is already example code to get me started. There is only a couple of things I need to change. Compared to the included humanoid model, my necklace humanoid is kinematically simpler, having 12 joints instead of 21. It is also a bit shorter, and significantly heavier. So I made changes to accommodate those differences. There he falls again, but this might be the last time as the necklace humanoid is ready for reinforcement training next. Once that is done, he would be walking, hopefully. Nvidia has provided a graphic interface to make the training and testing more straightforward. I simply select the task I just created, and click on Load. By default, 4096 copies of the necklace humanoid will be training simultaneously. That's a lot of humanoids in training. Like a chicken farm. But every one of them is going to collect experience, good or bad, and when combined that is going to accelerate the learning process. At the beginning, these poor guys have zero idea on how to move, so they apply random efforts to each joint, and the outcome is 4,000 robots falling down in all possible ways. The training task detects individuals that have fallen to the floor, by checking the height of its body, and restarts it to the initial state. I will stop rendering to allow my GPU to focus on training, but will periodically reopen the viewport to check how these guys are doing. Okay, it has been 5 minutes, how are they doing? Well, judging by the fact most are lying on the floor, I would say not so well. It seems instead of learning how to walk, They have managed to learn how to raise their butts high enough to not trigger the reset, so they can continue to collect rewards for being alive. Let me tweak the threshold for fall detection, and restart the training. No slackers are allowed on the training farm. Restart the training, and another 5 minutes later. Hey! Most of them are standing now. And they also appear to be moving, or more precisely jumping, with one leg. But they all seem to be moving diagonally instead of moving straight ahead. Where are they going? I have to say this is a bit creepy. The necklace humanoid could use another checkup on his leg joints. And it was quickly found out, his right knee was inverted, causing the shin to bend upwards. So, flip that problematic knee, and send him back to the training farm. Since I have changed joint definition, any prior training experience has to be thrown out. So reset the task and let it run another 5 minutes. That's much better, in terms of maintaining its heading direction, and less hurdling-like moves. Let the training continue and see if they manage to learn how to pick up some speed. Nice, nobody is falling anymore. "20 minutes into the training, the humanoid motion is now mostly set and further training will not alter its behavior much. So, that's it. The necklace humanoid has successfully graduated from the training camp, in which he has learned how to walk. But only on terrains he has been trained for. For things like running or climbing upstairs, he will need to sign up for future training sessions. And I will also need to study Nvidia's codebase in more detail for other more challenging training tasks. That's it for now, thanks for watching.